Welcome to my presentation. In this presentation, we shall find the derivative of a given function using limits. So, in this example, we want to find the derivative of this function f of x is equal to x cubed, like that. So, to be able to solve this problem, we will follow these following steps. As a first step, we're going to write the formula down. The slope of the function, or the derivative of this function, we can write this one out in terms of limits as limit as h approaches 0, f of x plus h minus f of x, this whole thing divided by h. And in the second step, we're going to substitute the given function in here as follows. Limit as h approaches 0, the given function is x to the power of 3. So x plus h, the whole thing raised to the power of 3, minus the given function is f of x is x to the power of 3, the whole thing divided by h, like that. And therefore now, as step number 3, we're going to recall some of the, let me write this a little more cleaner. We're going to recall the properties of cubes, and then we're going to state that if we have a plus b, the whole thing raised to the power of 3, we can write this one out as a cubed plus 3 times a squared b plus 3ab squared plus b cubed. That is the expansion for a plus b, the whole thing raised to the power of 3. In our problem, we have x plus h, the whole thing raised to the power of 3. This is very similar to expanding a plus b raised to the power of 3. In here, instead of a, we have x, instead of b, we have h. So we're going to write it in this similar fashion here. X to the power of 3 plus 3 times x squared times h plus 3 times x times h squared plus h cubed. So we're going to write this expanded form instead of x plus h, the whole thing raised to the power of 3. So in here, we're going to come back and then say limit as h approaches 0. The numerator part, we're going to write this one as x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed, and that is the one we have there, the whole thing divided by h. Now we can simplify it some more, and as we can see, we have a positive x cubed and a negative x cubed. We can cancel them out, and therefore we can simplify this some more as limit as h approaches 0. We can take out h common between the remaining terms, 3x squared h plus 3x h squared plus h cubed. H is common in the numerator part. So in the numerator, I'm going to write h. Take out h is common. We are left with 3x squared h. Oh no, there is no h. We have pulled out the h common. 3x squared plus 3x h plus h squared. Let us see whether we did the math correctly here. When we pull out h common between 3x squared h plus 3x h squared plus h cubed, when we pull out h common, we are left with 3x to the power of 2 plus 3x h plus h squared, the whole thing divided by h. We have an h in the numerator, h in the denominator, so therefore we can cancel that out. Therefore, when we simplify it some more, it is going to come out as follows. The limit of h as a h approaches 0, we can write this one out as 3x to the power of 2 plus the limit of this function 3xh as h approaches 0, and then plus the limit of this function h squared as h approaches 0. Now 3x to the power, the limit of 3x to the power of 2 as h approaches 0 is going to be equal to 3x to the power of 2 plus the limit of 3xh as h approaches 0. It is going to go to 0 because there is a h, the h is going to go to 0. 0 times 3x is going to be equal to 0. And then the last term here, the limit of h squared as h approaches 0 is also going to be equal to 0, and therefore we are left with 3x to the power of 2, like that. So this is the derivative of this particular function. So the way we can write it out is as follows. If the given function f of x is equal to x cubed, then the first derivative f prime x, the derivative of this function, is going to be equal to 3x to the power of 2, and that is what we have shown here with in terms of limits. In my next presentation, we shall see more examples on how to find the derivative of a function using limits.